Welcome to BKW Physics. I'm Mr. McConley, and we're going to do a little experiment here where we're going to fire a projectile launcher. The projectile will travel through the air, and I have some assistants, Joan, Fred, and Lou, who are all going to help take some measurements. They're going to measure the height, the maximum distance, so that's dV, dH. We have some timers off to the side. They're going to measure the time of flight. And we have Lou here measuring the velocity with a photo gate and the iPad, the velocity that the projectile leaves the launcher at. Now all this information we'll record, and then what we're going to do at the end is I'll allow my class to have time to actually calculate what the time should have been, compare it to the actual time, calculate how far it should have gone compared to how far it actually went, how high it should have gone, and all this information can be gathered from knowing the speed that the projectile leaves and the angle. And we're going to use a 65-degree angle that we just chose for this experiment. So, are all the assistants ready? All right. Lou, why don't we hit start there? Okay, everyone ready? Timers ready? 3, 2, 1, fire. All right. So, let's start. What do we think the height was? So, we think the height was... So 1.56 meters. Jot these down. We think the height, the dV, was 1.56 meters.
Should we start like here, or should I start at 5?
Yeah, it's right to the end, to the silver end of that. So right there. Yep. We think the distance, horizontal, was 2.66 meters. That's 2.66 meters of distance horizontal. And timers, what do you agree on? 1.25 seconds of time in the air. The angle was 65 degrees. And what do we get for a velocity, do you think?
Velocity looks about
5.5 meters per second, which makes sense with previous trials I've done. So I think we got good velocity there. So now the challenge falls towards you and towards the people in the classroom. Can you calculate what the time should have been? Can you calculate what the distance horizontal should have been, the distance vertical should have been, given 5.5 meter per second velocity at an angle of 65? Physics.